I'm John Waldo, Certified Six Sigma Black Belt, and I'm going to tell you the one thing you need to know about Lean Six Sigma and continuous quality improvement. This is just an overview. I won't attempt to teach the various tools and techniques here, but I hope you will gain an appreciation, if not an interest, in continuous quality improvement. First, a little Wikipedia background. Six Sigma is a method for continuous quality improvement, or CQI. It was developed in the 1980s at Motorola and embraced by General Electric in the 1990s. The term stands for product conformance within 6 standard deviations from the mean, or about 1 defect per billion opportunities in a controlled system, or 3.4 defects per million opportunities in production, or about 4.5 standard deviations from the mean. Today it refers to a broad spectrum of tools and techniques. The tools of Six Sigma have been around for decades, just not as a formal methodology. In essence, Six Sigma uses statistical analysis for the reduction of process variance in order to minimize defects through statistical process control, or SPC. The objective is to maintain process capability within upper and lower process tolerance limits. A close cousin which goes hand in hand with Six Sigma is the discipline of Lean. Lean is also a continuous quality improvement method. It targets reduction of waste in order to improve process efficiency. Six Sigma and Lean are so closely related that they are typically referred to as simply Lean Six Sigma. The operative factors for continuous quality improvement are cost, quality, and cycle time. The overriding objective is creation of customer value, defined as that for which the customer is willing to pay. The list is endless of tools and techniques associated with continuous quality improvement and Lean Six Sigma. Some of the more common Lean tools include A3 problem solving, 5S methodology, just-in-time manufacturing, Kaizen, Kanban, key performance indicators, Poka-yoke, spaghetti plot, takt time, total productive maintenance, value stream mapping, and others. The point here is that continuous quality improvement is a rigorous methodology. Here are some of the tools used in Six Sigma projects. Six Sigma includes tools such as 5 Whys, analysis of variance, general linear model, gauge R&R, scatter diagrams, chi-squared tests, check sheets, fishbone or Ishikawa diagrams, control charts, run charts, cost-benefit analysis, design of experiments, histograms, Pareto charts, process capability, root cause analysis, SIPOC analysis, or suppliers, inputs, process, outputs, customers, Taguchi methods, also value stream mapping, and others. Here are 2 types of Six Sigma projects. There are 2 primary types of Six Sigma project: R-DMAIC, often just DMAIC, and DMAD-V. R-DMAIC is used to improve a process. DMAD-V is used to create or replace a process. The 6 steps for R-DMAIC include recognize, define, measure, analyze, improve, and control. DMAD-V stands for define, measure, analyze, design, and verify. There is an entire industry of standards and certifications in these various techniques. In fact, the body of knowledge for an American Society for Quality Six Sigma Black Belt certification is in some ways comparable in magnitude to the curriculum for a master's degree program, and it would be beneficial if more master's candidates were prepared to lead continuous improvement efforts. But wherever continuous improvement is practiced, the entire method, approach, system, idea, concept, and theory of continuous quality improvement, the basic operative mechanism, can be summed up in one word. That one word, are you ready? That one word is probability. Simply put, continuous quality improvement is the use of valid and reliable methods to increase the probability of achieving desired outcomes. It's learning how to play the odds. Let me explain. The continuous quality improvement tools I listed here are simply activities which are helpful in taking advantage of the probable outcome of a series of events. Actually, any activity which takes advantage of a desirable probable outcome is appropriate for continuous quality improvement. It is strategy grounded in reason, observation, scientific method, and natural law, as opposed to opinion, authority, speculation, and desk theory. For some years, the focus was solely on customer satisfaction. This focus, sometimes referred to as romantic just-in-time, was kind of a field of dreams approach. That is, give the customer everything, and you will be rewarded. In contrast, a method such as the Great Game of Business by Jack Stack focuses on employee ownership of moving the bottom line. In this sense, Jack Stack and his Great Game of Business were way ahead of the continuous quality improvement advocates. In the Great Game of Business, page 77, he states, "There are only two ways to make money in business. One is to be the least cost producer. The other is to have something nobody else has." In the lexicon of quality, this could be stated as profits being generated by leadership in 1, cost, and 2, quality. However, in continuous quality improvement, a third factor is also included, that of 3, throughput, also referred to as capacity or cycle time. For instance, the most beautiful sweater imaginable can be knitted at very little cost, but even several sweaters a month won't pay for the kids' piano lessons. These three factors then, cost, quality, and cycle time, converge into the sole quality objective, that being the creation of customer value, defined as that for which the customer is willing to pay. This is entirely consistent with the prevailing equation for quality, price minus cost equals profit. The Great Game of Business has it right. Continuous monitoring of the bottom line does have an effect. Due to an observer or Hawthorne effect, the very act of measuring can improve outcomes. When people and processes are monitored, outcomes tend to conform to the stated goal. I have seen this firsthand. When downstream workers report results to upstream workers, process flow tends to regress towards specification. However, in order to optimize the numbers, we must eventually extend the focus beyond the numbers to the underlying process. This phenomena can be leveraged when coupled with time-tested waste reduction methods of Lean. The common types of waste addressed by Lean form the acronym TIMWOOD, or Transportation, Inventory, Motion, Waiting, Overproduction, Overprocessing, and Defects. The Great Game of Business also emphasizes the practice of the employee huddle. A basic tool of Lean is also a rapid-fire daily huddle. When properly implemented, the huddle can be harnessed to achieve almost unimaginable employee engagement and empowerment. Almost any constructive activity you do in a brief huddle can be beneficial. Simply recognizing process status can have a positive impact. I would take a 10-minute daily huddle over a 2-hour monthly staff meeting almost without exception. Huddles should focus on what is done, not the doer. Huddles create task cohesion as people become passionate about process instead of personality. This process engagement strengthens positive group cohesion. One of my favorite huddle components is the did-do round robin. What did you do yesterday? What will you do today? Rather than being oppressive, the did-do report provides a mechanism to recognize and acknowledge the remarkable things team members do every day that otherwise go unnoticed and are taken for granted. It's intended to recognize accomplishments, not penalize mistakes. In fact, it's entirely acceptable for anyone to opt out of the activity. A daily huddle can decrease the odds of dropping the ball and increase the odds of consistent base hits and an occasional home run. Huddles have a 10-minute target. Don't belabor discussion during a huddle. One of the basic Lean tools is the 5S or sometimes the 7S approach, which makes a great Kaizen project. The 7 S's are sort to eliminate what is not needed, set in order to organize, shine to clean, standardize to be consistent, sustain to perpetuate, safety to avoid harm, and security to protect ourselves and the community. Creating order promotes efficiency, which increases the probability of success. There is very little dissent on the benefits of being organized. Continuous quality improvement shares the same foundation as scientific method and is even an offshoot of it. The various areas of science are based on the likelihood of a variety of outcomes. In medicine, it would be the curing or healing of an illness. In meteorology, it would be the accuracy of a given weather forecast. In physics, it might be the likelihood of the occurrence of a given phenomenon based on theory. All are subject to natural law and seek to harness the power of probability to establish their validity. In business, the desired outcome is creation of customer value defined as that for which the customer is willing to pay. This is the source of profits, And in business, just as in science, there is fact and there is fiction. Unfortunately, the fiction comes in many forms. It may be transient popularity based on group psychology or flashy advertising with no real substance, even the veneer of accreditation or certification. It may come in the guise of industry awards or even prestigious titles, whether internal or external. But if the acclaim does not have a basis in stable processes with capabilities within acceptable tolerances, what appears to be fact may in reality be fiction. What appears to be Exxon may in reality be Enron, which gives rise to the three factors of quality. These are cost, quality, and cycle time. These are the factors which separate data from desk theory. Desk theory is the practice of strategy by speculation, as in the VP ruminating while reclining with feet resting upon desk, or as in boardroom interventions instead of breakroom interventions. Continuous quality improvement requires top-level endorsement of process-level empowerment. The following is a simple example of using lean principles to improve cost, quality, and cycle time to increase the odds for success. Here is a form I call a PIPE, which stands for Process Improvement Project Explanation, which I designed for authorizing a continuous quality improvement project. The project starts by recognizing an opportunity for improvement. This initiative is authorized via a form such as my Process Improvement Project Explanation, or PIPE. It's important to document continuous quality improvement projects in order to A. justify the resources, B. recognize and celebrate successes, and C. get better at getting better. A PIPE is one way to document a continuous quality improvement project. Here is a current state value stream map for a project streamlining a bookkeeping journal entry process. There's a lot of talk about tracking the numbers. This value stream map describes the process for generating the actual numbers being tracked. It focuses on the process of posting large bookkeeping journal entries. We see that the major source of journal entry errors is in the transcription step. One solution would be 100% inspection of all journal entries. This may reduce some errors, but this is a weak intervention and it would double cycle time for the step. So instead of the bookkeeper entering on paper, he plans to enter it on a spreadsheet template. Then instead of rekeying, the coordinator would upload the template, resulting in the future state value stream map shown here. There is then a decrease in cost for paper and labor, an increase in quality from far fewer keying errors, and a decrease in cycle time by eliminating the step of rekeying entries. This improvement would not be readily apparent by monitoring the bottom line or by simply trying harder. Instead, it uses a lean value stream map to analyze a process for the elimination of waste to create customer value by improving cost, quality, and cycle time. Now let's turn to the application of probability in a Six Sigma Ardemaic project. In any organization, there are innumerable opportunities for process improvement. However, if a process is not relevant to the key performance indicators of the organization, it is entirely possible to streamline a process which has no effect on achieving organizational mission. This is why it is crucial to have leadership buy-in for the establishment of a culture of quality. Even though a culture of quality must take hold at the grassroots level, it must do so with endorsement at the top. In this example, there are opportunities for improving quality of both product and level of service. So in order to focus the improvement initiative, we turn to the voice of the customer. This is an Ardemaic project making use of several quality tools organized with Minitab Quality Companion. First, recognize the opportunity using brainstorming, SWOT analysis, fishbone diagram, multi-voting, and a customer survey. Next, define the project as overcome sales stagnation due to customer attrition. Measure the current system with the attrition report using a computer test plan. Analyze the data and identify the root cause with the customer survey and attrition report. Root cause: the customer contact process is deficient. Improve the process. A customer relationship management system is implemented, resulting in order count and order size, generating a 67% increase in sales. Customer retention rate increases by 39%. Finally, control the improved process. The improved process is maintained by regular review. After several rounds of high-level analysis, leadership has isolated a need for investigation into customer retention, as is often the case. Customer retention is basically the activity rate of existing customers. The formula is simple, but quantifying it can be a daunting task. There are even cases where a company's transaction system is incapable of producing the necessary metrics. Customer retention equals ending customer count minus new customer count divided by beginning customer count. Customer retention can be a high-impact metric, especially if it has not been tracked historically. Based on a customer survey and other input, a customer relationship management system was implemented and customer reorder rates were measured with check sheets. The intervention was then analyzed to see whether there was a reasonable probability of a significant effect. The data was analyzed using a two-sample t-test in Minitab. The probability plot indicated normality. There was a difference in means with a 90% confidence interval. The intervention seems to be a success. The effect resulted in a 46% increase in order counts and a 14% increase in order size. This was accompanied by a 67% increase in sales over prior year. These graphs and tables are examples of some of the quantitative tools used in Six Sigma continuous quality improvement. There is a high probability that the intervention is associated with a significant increase in customer retention. The principles of natural law can also be applied to product improvement. Here we see a reduction in the average rate of product defects. However, when subjected to the Six Sigma method of gauge R&R, it is apparent that nearly a 44% contribution of variance was attributable to repeatability. In other words, the measured difference was due to the operators, not a product improvement. This is an example of using probability to detect a type 1 false positive intervention, thereby avoiding a potentially harmful misallocation of resources. Creation of customer value is optimized through a valid and reliable application of natural law. Guitar virtuoso Pepe Romero once said, "To play the guitar well is easy. To play the guitar poorly is difficult." The same is true of work and in many ways life in general. It can be miserable if our work is plagued with waste and inefficiency. Yet if we avoid waste and unnecessary strain, with effective leadership, our work can even be fun, as we perform our tasks with easy perfection. After all that, the one thing you need to know about continuous quality improvement and Lean Six Sigma is that the entire practice, method, approach, system, idea, concept, and theory, the basic operative mechanism of continuous quality improvement, can be summed up in one word. That word is probability. Continuous quality improvement is nothing more than learning how to use natural law to play the odds. Companies that don't learn how to play the odds are attempting to defy natural law under the improbable premise that they can consistently beat the odds. In contrast, when companies apply continuous quality improvement with insight and understanding, the odds favor creating a win-win strategy to consistently delight customers and reward stakeholders through the creation of customer value.